Hi, I'm Sandra, and in this video I want to show you what an abstract class is and also what an abstract method is. So firstly, to start off with an abstract class, you may have seen in a previous example, I have the shapes and shape subclasses, rectangle, circle and triangle. So the shape class exists to provide common functionality to child classes, and that means it contains methods that child classes will inherit and it saves them having to type them in. So it's for code reuse. The methods that will be used by the child classes are the get and set for color and the toString method. They can use that or they can override their own. So an abstract class, when you make a class abstract, you're saying that I can't instantiate it. I can't say shape S equals new shape. That simply will not compile. So it's saying that the purpose of this class is there as a parent to provide common functionality or methods that the child classes can inherit. So that's the first thing. Secondly, I'm going to include an abstract method. So an abstract method won't have a body in the parent class, and it says that all child classes have to provide their own implementation. If they don't, the child classes will not compile. So before I put in my abstract method here, look at the child classes up above. There's no red X's on them. They all compile. So I'm going to put in an abstract method here. It's going to be public, abstract, don't return any data type. It's going to be called draw, round brackets for no parameters. And traditionally you'd see a method with curly brackets, but you can't have curly brackets on an abstract method. It ends in a semicolon because it's forcing all of the child classes to provide their own body. It makes no sense for the method to be implemented here. So in this case, a shape. The draw method, it's going to print out, say, drawing a green triangle, drawing a 10 by 5 blue rectangle. So it's going to just print out a string of what it is drawing. It's not going to do anything fancy, I'm afraid, or any graphics on the screen. Now I'm going to hit the save button. Look at the classes up here, rectangle, circle and triangle. I'm going to save this class. You can see that they are subclasses of shape, and that means that they're being forced to implement, put in or override their own draw method, and it's not in any of them, and that's the reason that they don't compile. Another thing to note here, I'm going to take out abstract on this class shape for a minute and save that. If you have an abstract method, it must be in an abstract class. So I have an abstract method here. The class has to be declared as abstract for me to have an abstract method in it. It's not the other way around. You can have an abstract class that can't be instantiated without abstract methods, but as soon as you have an abstract method, the class has to be abstract. So that is one rule. Now I'm going to go into my rectangle class just to show you there. Rectangle doesn't compile, must implement the inherited abstract method draw. So that has to be put in, and the same for circle and rectangle. I'm going to pause this video while I go and just type up the draw methods just to save a little bit of time. Now to show you what I've put into the child classes. So firstly, the rectangle class. So public void draw, and I've put in a printf, just to make life a little bit easier. Now, a couple of things first. When you override a method, there are some rules. Firstly, just go back to the shape class. I've declared the abstract method in the parent class as public. When you override a method in the child class, it can't be less visible. So public is the most visible, so I cannot have it as protected default, which means no access modifier, or private in one of the child classes. If I attempted that, if I take out public, it's now default, that would not compile. So it can't be less visible. I can't reduce the visibility. So that's the first thing. Also, when overriding, I can't change the return type. It wouldn't compile if I changed the return type, and I cannot change the parameter list either, or of course the name. So everything has to be pretty much the same. The access modifier can't be less visible, return type same, name same, and the parameter list the same. Now I've used printf here in case you haven't seen that before. Printf, I've percentages where I want to insert a variable in there. So my first percentage, width would go into where the first percentage is. So drawing a out of 5 by the second percentage will go in, or the second value will go in where the second percentage is, and my third value there will go in where third percentage is. So %d is for an integer, %d, integer, and %s for a string. So it saves having to stop and start the string, concatenate, and can get a little bit messy doing that. So I'm using the width, the height, and the get color. I don't have get color here in the rectangle class. So super, don't have to put in super either, because get color would be inherited, so it's as if it's typed in. But it just makes it, clarifies it, that I am using the get color from the parent class. So that's the draw method in rectangle. Circle is going to say drawing a red or blue circle with the radius of whatever value, 6 or 7. And the triangle, drawing a green triangle. Now, how do I call that method? So in main, I have my shape array. I've got a rectangle, a circle, a triangle, a circle, the 2 circles, rectangle and a triangle in it. I'm looping through the shape array here, and that will enable me to pop in here if I want to. Just call the draw method on each one. So calling the draw method. So the reference type as I'm looping through the array is of type shape. So s dot, they're all void methods, so they do a printout. So s dot draw. That is a polymorphic invocation. So what that means is I'm calling, my reference type is shape, the parent, and which overridden method will be called is dependent upon the object type, and that will be determined at runtime. So it's calling the overridden draw method in each of the objects. Rectangle first, circle, triangle, and finally the second circle. And to run that. So now I have 4 objects there. So the first one, drawing 10 by 5 orange rectangle. Second one, drawing the circle, drawing the green triangle, and drawing the circle there again. So that demonstrates what an abstract class is, cannot be instantiated, exists to provide common functionality to all the child classes, and an abstract method forces all of the child classes to provide their own implementation. Doesn't make sense to have a draw to implement it here anyway, because drawing a what? A blue, green, triangle, rectangle, and as well in object orientation, the parent class has no idea what the child classes are, so it can't specify here exactly what it would be drawing. An abstract method cannot have a body, so hence the semicolon, and all child classes must implement it or it won't compile. When they implement it, can't be less visible, abstract will be removed in the child class, same return type, same name, and same parameter list, and that would be a valid override. And that is your abstract class with your abstract method.